Suzanne K. Langer talks about defining forms of classes in her Introduction to Symbolic Logic, page 116. Each defining form is like a complementary surface to a class. She gives a quick example of the class mortals, and the defining form of X must die. Kind of like Jacob Bronowski's examples above of, if this is really a mountain, we say, then the bearing of that landmark should be due east, or even the Shakespeare asking a question to test the concept. There's an example in Homer's Iliad of testing the perception. There speaks Aeneas, the wise counselor. Indeed yon man is exactly like Diomedes, if I may judge by the shield and the vizard, and I can see his horses. But I am not sure he is not really a god. If he is only a man, the clever son of Tydeus does not run mad like this without a god to back him. There must be some god beside him invisible, and he turned the shot aside even as it hit the man. For I have tried already, and I hit the right shoulder through the corslet plate. I thought I should send him to Hades, but yet I did not bring him down. It must be some angry god. Pandaros through Homer Iliad, chapter, book 5. The amount of progress on astronomical knowledge was so slow that our next great thinker after Homer is Thales. Thales' astronomical knowledge isn't nearly as significant as his mathematics. What's interesting about Thales' ideas is how similar they are to Genesis chapter 1 in the Old Testament. The idea of the universe here is the earth is created by the parting of the waters, and the sky is blue because they are waters in the sky. Thales' contributions were, according to the Greeks, he came up with logical proof and that he inspired others to also travel through Babylon and Egypt and bring back what knowledge they could find. Pythagoras is the next most significant mathematician to discuss. We've kind of already discussed Pythagoras' mathematics. Pythagoras, or Pythagoreans, came to see the earth as a sphere. Aristotle relates that they might have come to this conclusion by noting how a boat out in sea dips below the horizon. Pythagoras thought to combine music and mathematics, and the term music of the spheres is attributed to him. Today, we know music has nothing to do with the motions of the planets. But the idea may have led the Greeks to think that the planets had different-sized orbits. Each planet has a different speed, and hence a different sound, so each planet must be at different distances. A Pythagorean, Philolaus, thought of a counter-Earth to explain the eclipses and phases of the moon. It's a wrong idea that would later be corrected by an Anaxagoras. But I'll describe him a little later. Another Greek thinker in the Thales circle is Anaximander. Anaximander thought the earth was not being supported by anything, but still thought the earth was the center of the universe. He thought the universe was made by some arbitrary substance other than earth, wind, sea, fire, and that it was infinite. How else could the universe keep on going? He appears to be the first person to make the sundial. I'm not sure if he thought of this based on mathematics, but it is known that the gnomon is the basis of much of Greek geometric algebra. The gnomon comes from the Babylonian infinite series of figurate numbers. Take the square numbers 1 plus 3 plus 5 plus 7. So, 1 plus 3 equals 4 equals 2 to the power of 2, 4 equals 5 equals 9 equals 3 to the power of 2, 9 plus 7 equals 16 equals 4 to the power of 2. If you take a dot which equals 1, and then arrange 3 more dots to form a square to get 2 to the power of 2, and then arrange 5 around the square array of 4 dots, you get a larger square. You'll see a gnomon, or a carpenter's square. The carpenter's square is what they use to make a smooth surface. The gnomon is a right angle. And he used it to make a sundial, as already mentioned. And the gnomon was used in Greek geometric algebra, as axiomatized in Book 2 of Euclid's Elements. And Anaximander thought of evolution. He noted that a baby is helpless at birth. But animals are not. To go from self-reliant to helpless needed evolution. He even thought life must have come from mud. Anaximander thought there was infinite worlds, but not, as St. Augustine complained later, did he, any more than Thales, attribute the cause of all this ceaseless activity to a divine mind. Empedocles thought the universe was powered by love-hate relationships. We'll get to the significance of this much later with Kepler. Empedocles did come up with something scientifically significant by discovering air. He took a hollow sphere, with a hole on top and the bottom. He'd dip it in water till it filled up. He pulled the sphere out and watched the water fall back out. But then, another time, he filled it up and kept his finger on the top hole of the sphere, and pulled the sphere out. This time the water didn't pour out even though the bottom hole was still open. Somehow, something below the sphere filled with water was preventing the water from coming out. Even more amazing was when he drained his sphere, put his finger on the top hole, and tried to put the sphere in the water. This time, the sphere resisted being put in the water and didn't fill up. It was almost as if there was something in the sphere already. Empedocles had discovered air was something. Air was made of something so small that he, or anybody, couldn't see it. Democritus is generally credited by thinking of matter being made of atoms. He also thought of the Milky Way as being composed of millions of stars. Basically, he is noted for believing in a lot of discoveries by others. He was also written out of history by Plato. We'll get to Plato later. Parmenides is generally credited with saying the moon shone by the light of the sun. Anaxagoras, who lived around 510 to 428 BC, made the connection between this Parmenides idea and the phases of the moon and how eclipses work. Anaxagoras was jailed for his idea. This theory fritter away the deity into unreasoning causes, blind forces, and necessary properties. The Greeks were close to the heliocentric hypothesis. But Hanno, a Carthaginian, sailed to the edge of the Mediterranean, a little past the Rock of Gibraltar, which they'd have called the Twin Pillars of Hercules, and a little out into the Atlantic Ocean and reported no counter-Earth. Likewise, other Greeks traveled to India and reported no counter-Earth, so, the Greeks stuck to the Earth-centered theorizing. So, they continued to believe in a concentric spheres model of the planetary motion by a mathematician Eudoxus.